The P versus NP problem is one of the most important unanswered questions in computing and all of mathematics. But what does it really mean? Well, P or polynomial time problems are problems that can be solved by a computer in polynomial time. This means that the number of inputs into the problem and the number of steps taken to solve the problem has a polynomial relationship. For n number of inputs, the algorithm has n to the power of k steps. It's a bit confusing, so here's an example. Multiplying two-digit numbers using long multiplication takes 4 steps. Multiplying three-digit number takes 9 steps. Following the pattern, multiplying any n-digit numbers together takes n to the power of k steps, where k is 2. NP or non-deterministic polynomials can be solved in exponential time instead of polynomial. This means that for n inputs into a problem, the algorithm has k to the power of n steps. But the beauty is that the solutions to these problems can be checked in polynomial time. Let's say a computer has to guess a one-digit password that can be 0 or 1. It would take at most 2 steps to find the password. However, if we increase the number of digits to 2, the computer now has to go through 4 combinations. For 3 digits, it would be 8. We can see that for n digits, the number of possible combinations becomes 2 to the power of n. However, if you enter a correct password, the computer only checks each digit once to check if the password is correct. Therefore, finding a solution is difficult, but checking a solution is easy. If we plot these in a graph, we see that for NP problems, the steps taken increase drastically. NP problems are hard simply because they take such a long time to solve. However, computer scientists soon realized that some NP problems, like finding if a number is prime, could actually be solved in polynomial time. They just had to try a different set of steps. But that posed the question, maybe all NP problems can be solved in polynomial time. We just needed to find new ways to do them. That is the root of the P versus NP problem. Maybe all NP problems are actually part of P, but we just needed to find a new way to do them. How would you go around proving that though? Well, a number of NP problems called NP-complete or NPC can be generalized. So an easy way to solve one of them would work with all NP problems. And the most surprising thing is, NP-complete includes problems like Sudoku. So an easy algorithm to solve any n by n Sudoku would help with problems like protein folding, which would lead to a cure to cancer. The P versus NP problem is so majestic that solving it would throw us into a brand new age of problem solving. It also comes with a $1 million prize. But the problem itself is actually an NP problem. So is there an easy solution? We just don't know yet.